You have a question there. Just came back from Jakarta. What are we learning today? So we will be introducing computer vision today. We'll be going through some brief history about computer vision, of how this vision came by and how does this computer vision came by. Then we'll talk a little bit about the use cases of common or modern computer vision. Okay? Is there anything you want to ask me so far? No? So we'll start our class in 1 minute. So I can see that only one of you logged into this slides. I would like you to log in, as we'll be having some questions as we progress. So will you be covering assignment 1 and assignment 2 today? I'll be covering assignment 1 and assignment 2 in the practical this week. Regarding tomorrow being off, do you have any other class to do? Any replacement class? So what do you think? Would you like to have a replacement class, or would you like to join just another class? I do have other classes on Wednesday, so that should be 6 to 7, 7 to 8. Otherwise, I will provide a recording of the tutorial itself. Okay, so for those whose practical classes falls on tomorrow, feel free to join my another 2 classes from 6 to 7 and 7 to 8 on Wednesday. Okay? Right. So if we don't have any other question, let's just begin our class today. So, sorry, it's week 2. So, it's week 2. So today we are going to talk a little bit about introduction into computer vision. So what are we doing today? Just a quick recap on what have we covered last week. So last week we mentioned that the main objective of computer vision is to build intelligent system, is to allow machines to see and think and therefore act like human. So the main objective of this computer vision is really about building some artificial intelligence system that is able to learn from data and experience and therefore can behave like human, can see and respond like human. So in order to allow this to happen, it takes mathematical algorithms in the field of machine learning to build that system which can learn and adapt from data. So that field of study essentially is called the machine learning. And a subset of machine learning emerged as a very important field, which is a type of machine learning with many layers, loosely inspired by the brain structure that enable this computer vision to flourish further. We will look into it in today's lecture. So then, that sums up the current technique, which is most popular in computer vision, is the deep learning, a subset of machine learning. So this is so far what we have covered last week. So for today's lecture, what we will be talking about will be a brief history of computer vision. So we'll first talk about how this computer vision came by, and then we'll talk a little bit about how this deep learning field evolved from the beginning until today. Then finally, we will also spend some time to look through some of the use cases or applications of machine learning techniques in today's world. Okay? So first of all, we are going to dive into the brief history of computer vision. So the history of computer vision started back then in 1959, where this group of researchers, they have no interest in anything related to computer, but they are just interested in a field of research called vision. So what are they trying to do is to study how this how things are being perceived by a human's eye. So this is called the visual perceptions. So what they are going to study is how these visual things are being perceived in mammals' brain, perceived by mammals' brain. So the study is really about visual perception in mammals that begins with a detection of simple structure, which is oriented edges. So what are they trying to do in this piece of research is essentially, they have this electrode, and they sort of plug this electrode into a cat's brain, into the visual cortex of the cat's brain. What they are trying to do is to trace some signals from this electrode from the visual cortex of this cat's brain. What they are going to do is they have this electrode in the cat's brain, and they have this cat to look at some images. So those images include these patterns that is being flashed repeatedly to the cat. So then, as the cat is looking at those pictures, there is some signals which is being captured. So what they found is that there are 3 levels of cells which can respond to these images of how this cat's brain is responding to these shapes. So what they found is that in the simple cells, it responds to the light orientation, whether there is a light or whether there is no light. And then they also found that the complex cells responds to light orientation as well as the movement of light. Then finally, they found that the hypercomplex cells will respond to the movement with an endpoint. So this is a very important discovery where they found that whenever there is a signal, as this image is being flashed, there was no response in the cat's brain. However, when they move this pattern slightly by a little bit, so as we see an endpoint here, there is a stimulus that is triggered within this cat's brain. So what's really important from this piece of work is that they found that the first level of hierarchy of this visual perception is the oriented edges. So essentially, this is very important and very related to computer vision because that is how we enable computer to see things. Edges, the first level of recognition should be edges. So then point 2 of this takeaway in how is this related to computer vision is that there are the next level hierarchy of neurons that responds to more complex structure is the shapes and objects. So after recognizing the oriented edges, the next step that a computer vision should learn is essentially the shapes and the objects. And finally, be able to interpret the semantic meaning of these shapes and objects to give itself an overall meaning of visual scene. So that's 3 levels of findings that is being extracted from this piece of work. So this piece of work have won the Nobel Prize in 1981. So it is very significant in the field of vision, as well as the idea is also borrowed into computer vision field. So then, another very significant research or advancement happens in 1963 by this Larry Roberts. So by far, this is so-called probably the first PhD thesis that is known in the field of computer vision. So what happens is, in this work, Larry Roberts, he sort of like simplified the visual world into basic geometric states, which aims to recognize and reconstruct shapes in the world, shapes of objects in the world. So then, this piece of work is pretty influential, but this Larry Roberts then moved out from computer vision, and he ultimately became one of the person who created internet today. Yeah. So then, in 1970s, David Marr is another iconic person in the field of computer vision. What he has drafted is a conceptual framework for vision. So what he proposed in the field of computer vision is that once we have the input image, we should then detect the edge of the image, which then allow us to do further sketch that leads us to create a 3D model representation of object. So then, in 1970s, it is also in the field. There is also this advancements where people are looking into recognition, object recognition through parts. So what they are trying to do is to try to represent objects like human into shapes and geometric configurations. So say, for example, there are two models proposed which are quite popular. First of them is whether we can represent human into simple cylindrical structures, so generalized cylinders, or can we actually represent human with these pictorial structures? So that is about representing objects in parts. So then, as we move into 1980s, so this is the time when digital cameras become more and more popular. Therefore, people are getting more and more images and starting to think about how can we represent objects using edge detection. So in the example that we are showing here is that we are taking a picture of multiple pieces of razors and then trying to detect the edges of every single razors from this image and see if we could actually detect other razors from other images. So then, that's 1980s, and moving into 1990s, what people have been rethinking about is how can we then segment image. So segmenting image requires some grouping of pixels into parts. Say, for example, people have been thinking about whether can we group the same pixels into representing it as a human, whether we can segment these pixels, similar pixels, into clothes, or whether we can segment these images and say these items are umbrellas, things like that. So that is about 1990s. So then, moving into 2000s, so people are beginning to look into recognition in matching. So the problem that people have realized from the past research is that, say we have a similar object as a stop sign, but when they are represented or taken in a different angle, using a different angle, how can we then recognize them as a similar object? So the idea that is proposed is called SIFT in object recognition, where the main idea is whether can we use some important points of a particular object to represent that particular object, which then allow us to match from one point to another of the same object in different images. So that is recognition through matching. So then in 2001, there is a very significant breakthrough in this computer vision field. So that field is face detection. So this piece of work is conducted by Vola and Jay. So it was one of the first computer vision technology which then be rolled out or be used in an actual applications, actual physical applications. So what happens is people have been able to detect faces. So once this algorithm is being created, Fujifilm at that point of time, when digital camera, which we use with a click, was popular, they have incorporated this algorithm into their camera, which allows this user to then click halfway, be able to detect the human within the structure and take a picture. So this was a very significant breakthrough of the applications in the field of computer vision research. So that is face detection. So of what we have discussed so far, the experiments and research are conducted by different researchers, and every researcher they have their own different idea, and they are just doing things in silo. So one group of researchers can be researching on field A, another one field B. So then people have been thinking about how can we make this field of computer vision advance a little bit further. So what happened is that this group of researchers, they have done, in 2000s, this is when internet became more and more popular, and we also have more and more images available online. So this group of researchers have been thinking about whether they can curate a standardized data set, image data set, so that we can standardize the field of computer vision research. So what they did was download a huge library of images that consists of 20 object categories. And what they did is they make the graduate students to go and technically categorize or annotate every single object. So that now we have the downloaded images, and we have the annotation of each image, of what each image is about. So then these sets of image with its annotated label allow us to then look into how do we teach computer or use machine learning algorithm to classify object. So that is a field of image recognition. So as you can see, once this data set is launched, it is called the Pascal Visual Object Challenge. So they have launched this huge library of data set images, and they allow people to train or to develop machine learning models. And as we can see, year by year, the mean average precision of this machine learning algorithm are just getting better and better. Okay, so now the world has more objects than 20 categories of object. So then another group of researchers then think about how can we scale this up, meaning they have created an even larger data set which consists of 1.4 million of images, which consists of about 1,000 object classes. So they launched this as ImageNet. So with the scale of images of 1.4 million, it is almost impossible to get the graduate students to manually annotate every single image. So what they have done here is that they push this image to the internet, and basically they allow people to annotate it and pays a very small amount of money to people who is willing to annotate these images. So say, for example, people who have time may want to annotate this image and get paid a little. Say, for example, housewives, they have some free time, which allows them to earn some extra errands. And also some students who are potentially also doing some annotation work behind there to earn some extra errands. I hope nobody is doing that right now. So that is called the ImageNet Large-Scale Visual Recognition Challenge. So this large-scale visual recognition challenge is still ongoing until today. But what is really important here about this ImageNet is that this data set is launched in 2009. And people have been training machine learning model to try to recognize things from this set of image. So this is some of the winners, some of the performance of the winners year by year. So over here at the last bar, this is how good a human is at doing this image recognition task. We can see that the error rate of human in recognizing the items in this image is about 5%. Okay, so now that is our benchmark of performance. So then in 2010, we can see that the initial winners of this ImageNet, the error rate of those machine learning algorithms is pretty high, that is about 28%. And then the next year, we see some improvement, very small improvement, that is able to improve the error rate from 28 to 25.8%. So that is a very small incremental improvement. But as we move on to 2012, this is a very significant time point where people have been able to develop an algorithm that is able to reduce the error rate from 25.8 to 16%. Well, this 16% is still quite a distance away from what human can do, but this is an important timeline because the model that has won this challenge is called the AlexNet. And this AlexNet is one of the very early computer vision architecture that is able to do this task at this error rate. So it is a very fantastic deep learning architecture, and we shall look into it later or in our classes in the future. So as we move on, we can see that in 2016, the error rate has been reduced to on par with human, or even better than what human can do. So these are all because of the development or the advancement of deep learning architecture. So AlexNet is one of the very significant deep learning architecture which goes into mainstream in the early phase. So that is how computer vision has been able to flourish and advance in ever since then. So now we wanted to look into how do we came about this deep learning architecture. So at that point of time, all the researchers are surprised with how well a computer or an algorithm can predict object with such low error rate. So people have been thinking, where does this idea come from? Is this something new or is this something incremental? Well, it is not something very new at that point of time. It is just that this group of researchers happened to use that idea to win this challenge at that point of time. So the history of deep learning traces back to 1959, which we will look into it later. So before we move on, do you have any questions on the slide so far? 3, 2, 1, no question. So then I do have some question. So based on what we have covered so far, which of the following do you think have become a major focus in computer vision research around the year of 2000? Fingerprint recognition, real-time face recognition in videos and images, depth perception for 3D scene. Huh? Okay, so the correct answer is real-time face detection algorithm, which is being applied in digital cameras. So that perception was a significant a piece of work in 1980s, not 2000. Okay. So in the 2000s, two influential image data sets, Pascal and ImageNet, emerged. So what was the primary purpose of this data set? Is it to archive historical photographs? Is it to develop special effects for movies and video games? Or is it for the purpose of training benchmark algorithms for object recognition? Well, obviously, everyone get this right. So the one who answered this, hello, wake up. So now, clear on how this computer vision came about since the early days to current. So now we'll look into the brief history of deep learning, because deep learning is a very important technique to enable modern computer vision. So the history of deep learning traces back to 1958, where this piece of a huge machine is called a perceptron. So ultimately, this machine is known as one of the earliest algorithms that can learn from data. It is actually an algorithm where the weights are stored in the potentiometer, which is updated with electric models during the learning. So this whole piece of item itself stores some weight that is able to change as it receives different signals or stimuli. So don't ask me how people create this, and don't ask me how the weight is being updated. I do not know that. But ultimately, this is one of the earliest known algorithms where the weights are actually physically built into the physical weights. Okay. So now, when this piece of thing is connected to a camera, it was able to recognize letters of alphabets from this camera. So this is one of the very early stage of perceptron known in the world. So then this idea of perceptron become something that is possible to look into to enable machine to learn and see from data and experience. But then in 1969, these researchers, Minsky and Pepper, they published this book. So the implications of this book is that they mention that there is certain limitation with this perceptron, and therefore the whole world sort of became uninterested in perceptron, and therefore the research in perceptron ceased during that time. Not until 1980, some researchers begin to believe in a computational model and also visual system. So this Fukushima in 1980s, they have proposed an architecture called neocognitron. So what this neocognitron is about? So they borrowed the idea from the CATS experiment, so where they conceptualize that a computational model of visual system, they should consist of a hierarchical steps that is made up of complex as well as simple cells. So what they propose is the interleaved simple cells known as convolution and complex cells known as pooling. So they are proposing from layer to layer as an architecture of how this computer visual system should work. But the bottleneck of this piece of proposal is that it is merely just a model or a concept without mathematical algorithms behind it, and therefore nothing can be done from here. No trainings can be done from here. There is no practical training algorithm from this piece of work. So then one of the most important call out from this piece of work, from this concept, is also we can see that it looks pretty much like the AlexNet in 2012. Yeah. So then in 1986, a group of researchers, they proposed this backpropagation. So backpropagation is a very important mathematical algorithm which enable people to begin to train neural networks. So, so this has been successfully applied into multiple perceptrons in a lot of layers. So we'll look into this backpropagation as we study the neural networks next week. So then in 1998, we have seen another very important piece of work called the convolutional networks by Yan LeCun et al. So this piece of work have created an algorithm that allows these machines, that allows people to recognize handwritten digits. So digits from 0 to 9. So this is very important because the availability of or the success of this algorithm has allowed a lot of banks back then to read handwritten checks digitally. So that is improving the efficiency of banking industry in order to process multiple pieces of checks back in those days. Okay. So then in 2000s, the research switched gear to this field of deep learning. So in 2000, this is when deep learning is being coined. Why is it called a deep learning? Is because people are trying to create neural network that goes beyond 3 to 5 layers. So the neural network sort of gets a little bit deeper and deeper and deeper, and therefore people are naming this field of research as deep learning. And that is how the field of perceptron evolved into neural networks, which then evolved into a field of research called the deep learning. So then, ever since then, as we have better computers, better computational devices, we are able to train deeper neural networks. So now, over here, what we see on the screen are some trends of deep learning. So according to Google Trends, we can see the amount of interest or the availability of these deep learning algorithm or models available is increasing from year to year. And on the right, this shows the statistics of the number of deep learning algorithm or models that are proposed in a very significant computer vision conference year by year. So people have been developing deep learning models in multiple domains, which causes this field to flourish even further. So that is from 2012 to present. So there's a lot for us to learn in this deep learning field, and that is the reason why we are going to learn about how to apply deep learning in building systems that allows computer to process and respond to image data. So, any question? Now, can you share the code again? Yeah, sure. Maybe later. Six seconds. 6, 5, 4, 3, 2, 1. How do you think people back then thought of developing a perceptron? I have no idea, but they are just very, very smart people. I think the motivation of building perceptron is probably some people want to decode certain things a little bit faster, especially during the wartime. People have been trying to see how to automate the task of deciphering codes from enemies, which is why I think people are doing this fancy thing. Love this class. Thank you. I hope you love this even more. Are you married? Secret. I made the table already, but it is very small. Why is it called deep learning? It is called deep learning because people have been training neural networks from a few layers into multiple layers up to thousands of layers of neural network. Can we go out dinner? Hang in there. So, question. The AlexNet architecture is one of the very important architecture introduced in 2012. So, what was the key factor that contribute to this AlexNet? Is it the ability to process images directly from smartphones? Is it the implementation of large-scale cloud computing platform? Or is it a deeper convolutional neural network architecture compared to previous model? Yay. That's very straightforward. Okay, next question. So the pioneer in deep learning research, which type of artificial neural network architecture is he known for developing? Is it CNN? Is it GANs? Is that RNN? So he is known for creating the model which is able to differentiate 10 digits from 0 to 9 using convolutional neural network. Okay, so finally we have about 13 minutes. So we are going to cover some common use cases of this computer vision. So as the field is coming to a more advanced and application-ready stage, let's take a look at how far have we come. Every single application right here is very strongly related to the availability of convolutional neural network. So ConvNet is a short form for convolutional neural networks. So they are everywhere since the 2012 until present. So we can see that convolutional neural network is one of the most common architecture or the types of deep learning architecture that is used in image classification as well as image retrieval. So these convolutional neural network have then been evolved into some other architecture that is able to detect objects from images. So there is a difference between object classification and object detection. And ultimately, the difference is object classification allows you to tell whether this image is a certain item or is not a certain item. But object detection is a field of research which trains the model to detect certain items, detects and locate certain items within a certain image. So what it takes is location information, as well as detecting, classifying the items within the bounding boxes and tell what item it is. So it is a very huge model to start with. So then CoffNet is also used in image segmentation, where you see that people has been trying to group pixels of a particular item together to represent a single object. So then CoffNet is also commonly used in video classification because it has been able to classify image. It has been able to locate an image, to detect the image, and therefore it is also being used for video classification, as it was able to classify and detect multiple items from a moving images. So then pose recognition is also one of the very important research area in this computer vision, and people are even using this CoffNet image classification to try to detect objects in games to then predict what should be the next steps. So we can also see how this image classification within the field of computer vision is being used in medical field. It's used in whale recognition, as well as like galaxy classifications. So basically we just have images and get this algorithm or CoffNet to recognize what the image tells us. So that will help human in automating a lot of tasks. So then as we advance into further research, what is very, very active within the field of computer vision research is image captioning. So what it does here is, how can we train a model that sees and reads the image and provide us the captioning? Okay, so this is a field which is still very active, and let's see how does it do. So say, for example, this image captioning ability, how it reads this image is that it says there is a white teddy bear sitting in the grass, which seems pretty right. In this image, it says that there is a man in a baseball uniform throwing a ball. Do you think that is very accurate in a sense? Is a person trying to throw a ball, or is a person trying to catch a ball? So, yeah. So we know that there is a certain limitation here. And in this image, the captioning says a woman is holding a cat in her hand. So, which I don't think the woman is holding a cat, whereas she's just wearing a very furry blouse, right? So this is where the research field is about. So have you been thinking of, what do you think about the most significant applications or of this ability? Anyone started the assignment yet? Is there any template for individual assignment for MLPC, or we can just take and modify from the template? Yes, you can just take and modify from the template. Vision is going to make humans' life a little
MLPC
bit
question
better.
in cvnlp class.
The success of image captioning, in my
MLPC
opinion,
individual
is going
assignment
to
consists
make
no
our life
coding,
so much
correct?
easier,
No
as in
coding,
if
just
it is
proposal
being
of
brought
ideas
into a
and
device
literature reviews.
that is
Yes,
able
correct.
to be a company of a blind. The blind can essentially see things that
Not
the normal
really,
humans
because
see.
I think the terms you use are
Okay.
quite hard to understand.
So as a summary, what we just talked about
Maybe
is
with
the
more
computational
examples could
advancement
help.
in this computer vision field.
Okay,
We talk about the availability of data sets
Got
which
you.
enable this field of research to flourish.
Which
and
terms
we also
are
talk
quite
about
hard to
some very
understand?
significant and important
Can you
algorithms
specify any
within
difficult
this
words?
computer vision that allows us to perform image classification,
Or maybe you can
object
tell me
detection,
during
so far and
tutorial
so
or
forth.
practical class. Okay?
So, yeah, before we end the class, I just have one more question. Do you think computer vision is a good thing or a bad thing?
Did you remember anything from the
Okay.
previous lecture? You
No
don't?
one's here anymore. So sad.
Huh?
Well, thank you.
Are you serious?
Okay, 3 of you thinks that computer
Dinner?
vision will make our
Yes,
lives safer.
feel free to have dinner inside this
Okay,
class.
by
Just make sure that you
detecting
clean up the mess.
activities.
Okay?
Some of you think that it will
Thank
lead to
you.
loss of privacy
Love your
for
teaching style
individuals.
and answering
Okay.
questions. Yeah, you will be
Some of
expecting
you
more
think
questions
that
from me, yeah?
development of computer vision
Hope you love the final
should
exam
be
questions
prioritized
too.
over other technological advancements because of
3 has
potential
fallen.
applications.
Oh yeah, I heard about the
Well,
news.
it's good to know.
Hope no one is trapped.
But in my personal opinion, I think that computer vision is something that is good. It is
MLPC
going to
again.
make our life so much
MLPC,
better.
are we learning basic
But at the
algorithms?
same
Yes, we are
time,
learning
I do
basic
think
algorithms.
that
Are there any
there is
advanced ML algorithms
another
you're gonna
field
learn?
which is
What
pretty much
what
important,
advanced
that
ML
is
algorithms?
How do we govern
learning,
the use
neural
of
network,
this
and deep
technology,
learning.
computer vision technology? As of today, we see a lot of apps that collects your images and then impersonating you, of calling your family members.
No one remember
to do
anything
bad
from the
things.
previous
So
lecture.
that happens, and I think aside of computer vision, another field of governance is also relatively important for
So
in the field
this
of
debate
CE.
and discussion
So with
returns.
this, we end our class. For those who are having tutorial, I'll see you in tutorial class. So next week we are going to talk about, take a step back. And
Nobody
talk
remember
about
anything from the previous lecture.
digital images. Then we'll also look into some NLP, some computer vision tools which
The
are
only thing you remember from the
open
previous
CE.
session is assignment.
Open for questions.
Great. Some history. Yes, some history.
I'll see you next week.
Supervised learning. Supervised learning, are you sure? Supervised learning was mentioned in MLPC class, not CVNLP, yeah? No, this term is not mentioned at all. No. I think because history is boring. Got you. Okay, history is boring. It was basically about the review of history with first focus on computer vision. Then we follow the algorithm as well. Yes, that's right. Have you seen the AI brandings? Like AI rice cookers, which are just using some smart screen tag from 2011. Yes, I suppose. Let it go. Don't let it go. Hang in there. Okay. So, does anyone still need the attendance code?
Either join the class today, so which happens now. So it is the location of this tutorial is C706. C706, yes.